Hello everyone, I'm Mohammed Islam Shishir, and today I'm going to be solving this problem called container with most water. So in the description they're saying that you are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of ith line are I comma 0 and I comma height of I. So what they're actually trying to say is that they're going to give us an array with height of the lines. So we can call them columns for this example. So we are going to get the height of the columns in the array. That's it. And find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. So the solution of this problem needs a little bit of visualization. So let's go to the board here. So yeah, as we can see, we have the height of the columns given inside the array. So we have to any two columns can form a container. So if we consider this one as the left side column and this one, left side column, and this one as the right side of the container. So okay, maybe yeah, if I say it this way it would sound better. So if we consider this column as the left side of the container and this column as the right side of the container, so this is going to be our container. And if we pour water here, water will get spilled out from here. So the maximum amount of water this container can hold is 1 unit of water, because the lowest the column with the lowest height, the lowest column has the height of 1. So the maximum amount, the unit of water it can hold is 1 unit. And we have to also consider the distance between the two columns. So the distance between this one and this column is 1 unit, 2, 3, 4, 5, 6, 7, 8. So 8 into 1 is 8 units of water. So, and if we consider this one as the left column, left side of the container, and this one is the right side of the container. So and this is the column with the lowest height. So the maximum amount of water this container can hold is 7 units. So, and the distance between these two columns are 1, 2, 3, 4, 5, 6, 7. So 7 into 7 is 49 units of water. So yeah, so here we have recognized a pattern here somehow. We are always choosing the column with the lower height to get the water amount or water unit. And we also have to consider the distance between the two selected columns. So what we have to do is that we have to get the minimum height of left column and right column, and also we have to get the distance between the two current columns. Then with the distance and the height, or for this one, height is considered as water unit, so the lowest height is considered as a water unit. So the water unit and the distance, if we multiply both of them, we will get the amount of water. And we are going to loop through each of this column, and we are going to consider each container and calculate the water amount, and we have to return the maximum amount of water. So yeah, so maybe it was a little hard to get at first, but maybe if we go through this step by step it will be easier to understand. So the thing is, initially the maximum water amount is 0, current water amount is 0, everything is 0 initially. So yeah, so first of all we have to get two columns. So let's consider the leftmost column and the rightmost column. So so we are at, so if we are if we have two pointers here, so the left pointer is going to be pointing at the leftmost column and the right pointer is going to be pointing at the rightmost column. So yeah, and then we like if we consider this one and this one, so the leftmost column is at index 0 and the rightmost column is at index 8. I hope so. So 0 1 2 3 4 5 6 7 8. So yeah, so for this one the distance is 8. So let's update this. Distance is 8. So and the lowest column is the height of the lowest column is 1. So minimum height is 1. So the current water amount is going to be 8 into 1 is 8. So the maximum water amount is 8 at this point. So now what we have to do is that we have to get rid of the lowest, yeah, we have to get rid of the lowest column, because if we get rid of the highest column, it will like we don't have a guarantee that it will land to a higher column, right? So getting rid of the lowest column sounds like makes sense. So if we get rid of the lowest column, we might end up getting better output. So yeah, this is not going to be here. So 8. Okay, so like we will always get rid of the lowest column. So if we like update the pointer of the leftmost column, it will land to this one, index number 1. So for this one, the lowest height is 7. So let's update the minimum height. Minimum height is 7, and the distance between these two is 1 2 3 4 5 6 7. So distance is 7. So the current water amount is going to be 7 into 7, which is 49. So maximum water amount will get updated. We will always get the maximum from these two. So yeah, this will get updated. So the minimum column here, the minimum the column with the minimum height here is this one. So we will get rid of this one right now, and so we will update the right pointer, and the right pointer will land to this column. So now this is also the lower column at this point, so which is at 3. So the minimum height is going to be 3, and the distance is going to be, if the left pointer is pointing here and the right pointer is pointing here, so the distance is 1 2 3 4 5 6. So 6. So 6 into 3 is 18. Is that like, are we getting 18 units of water here? So this is it. 3 3 6 9. Okay, it's, yeah, it is 18. So yeah, so as we can see, the current water amount is 18 and the maximum water amount is 49. So the maximum water amount is not going to get updated. So now the lowest column is this one, so we have to get rid of this one. So we are going to update the right pointer. So the right pointer is going to be here. So now if this is the right pointer and this is the left pointer, both of the height are the same. So in this case, it doesn't matter which column we get rid of, like both of the column are of same importance, so it doesn't matter, we can get rid of any of them. So let's just calculate the water amount for these two columns. So if the minimum height is 8 and the distance between these two is 1 2 3 4 5, so 5 into 8 is 40. So the current water amount is going to be 40, and the maximum water amount is not going to get updated because 40 is lesser than 49. So yeah, that's basically it. Let's just go to the coding part, maybe that would be easier to understand. Okay, so yeah, so we will get to pointers here. So left is going to be 0, right is going to be height. Let's copy this, height of length of height -1, and maximum water count, max water is going to be 0. Now let's meet in the middle. Okay, now let's calculate the distance between these two. So the distance is going to be right minus left, and also we will need the minimum height of the containers. So min h is going to be min of height of left, height of right. And so now we will get the water amount. So the current water amount is going to be distance into mean height. Okay, now let's update the max water count. So max water is going to be maximum of max water and current water. So that's it. And to update the pointers, we will need a condition. So if height of left is less than height of right, we will update the left pointer. Otherwise we will update the right pointer. So now if we return the max water amount, this is going to give us the correct answer. Okay, it didn't because I messed up. So it's going to be size. Now it should work. It didn't. Why is that? Distance into mean age. Type int. Right minus left. Right is height of size -1, left is 0. Height of left, height of right. Distance into minimum height. I don't see any problem here. Okay, let's go through this step by step. So int distance equal right minus left. Distance left plus plus right minus minus. Let's see if we are getting the distance. Okay, we are getting the distance. So mean height is going to be minimum of height of left and height of right. So let's see if we are getting the mean height properly. Yeah, the minimum height for the first iteration is 1. So yeah, that's good. Now let's see if we are getting the water amount correctly. So into distance. Okay, so what was wrong? So max water is going to be max of max water and current water. Okay, and we are going to update the pointers based on the height. So if height of left is less than height of right, we are going to update the left pointer, otherwise we are going to update the right pointer. So yeah, this worked. I don't know, maybe there was a bug. Okay, now this should get accepted. Okay, now let's do this for Python. Okay, again we're going to get a left pointer, a right pointer, and max water count. So left pointer is going to be at 0, right pointer is going to be at the last, okay, length of height minus 1, and max water count is going to be 0. So while left less than right, we are going to calculate yeah, we're going to get the distance. So this distance is equal right minus left. So mean height is going to be height of left minimum of height of left and height of right. So water count is going to be distance into mean height, and max water count is going to get updated. Max water and water. So again, if height of left is less than height of right, left plus equal 1, otherwise right minus equal 1, and at last we are going to return max water. Let's run this. This should get accepted. Okay, it does. So we can just like reduce the number of lines. So what we can do is that, yeah, so water count, we don't have to put distance in another variable. That should also work. And if that's the case, we can just, yeah, put this here. So this should also work the same way, right? So let's submit this. Yeah, it gets accepted. So now we're going to solve it in Ruby. Okay, left pointer, right pointer, max water. So left 0, right is height dot length minus 1 and 0 height, while left less than right, calculate minimum height. Mean height is minimum of left and right dot min, and max water is going to get updated. So max water is going to be max water and mean height into right minus left dot min. So now we just have to update the pointers. So if height of left less than height of right, then update the left pointer plus equal 1, otherwise update the right pointer minus equal 1, and lastly return max water. This should get accepted. Okay, it didn't because I messed up somehow. So yeah, everything's right here. So minimum height, let's see if we are getting the minimum height correctly. So min h, yeah, now max water is going to be max of, sorry, max water and mean height into right minus left, that should give us the distance, dot max. It should work. Okay, it did. Maybe I wrote min or something. So yeah, this should get accepted. Yeah, now lastly let's solve this in JavaScript. So again we are going to follow the same approach. So left equal 0, max, right is equal height dot length minus 1, and max water count is going to be 0, while left less than right, mean height is, okay, let's just get let max min from math. Okay, I hope this works. So min of height of left, height of right, and max water is going to be max of max water and mean h into right minus left. Again, if height of left less than height of right, update left pointer, otherwise update right pointer. Return max water. Okay, need a semicolon here. Yeah, let's see if this works. It does. Let's submit this one. Okay, so yeah, this was the solution for the problem container with most water. So yeah, that was pretty much it. Maybe I explained it Like my explanation was a little lengthy, but yeah, I don't know if you guys liked it or not, so let me know in the comments. And yeah, thank you very much for watching. Hopefully I'll see you next time. Thank you.